Hi, in this video, we're going to talk about Ethernet MAC addresses. Okay, so if you should be familiar with hexadecimal digits. If you're not, take a look at the video on number systems, hexadecimal numbers. Okay, so Ethernet MAC addresses are represented by or composed of 48-bit values. Okay. So Ethernet MAC addresses are embedded on the Ethernet card, and they're 48 bits. Now we represent those as 12 hexadecimal digits. So each hex digit, remember, one hex digit equals 4 bits. Okay, so that's how we get our 48 bits. The Ethernet MAC address is divided into two parts. The OUI, organizationally unique identifier, that should be organizationally, add another LY to that. And the vendor assigned or unique identifier. Okay, so the first 24 bits, the first 6 hexadecimal digits, is actually the vendor code. Okay, so IEEE maintains this and allocates these codes, but every vendor will get one or more 24 bits shown in hexadecimal digits, like Cisco here. This is one of Cisco's 6 hexadecimal digits, 24 bits that belong to it. So that represents that vendor, and typically it represents to that vendor a specific model card. So Cisco, Intel, 3Com, whoever will typically have many different OUI codes. For a single OUI code, there will be another 24 bits that uniquely identify that card. So for example, this Cisco one here, 00602F in hex, this specific code for this specific NIC card is 3A07BC, the vendor assigned interface value for it, the last 24 bits. But there's going to be many cards that have the same OUI. Just different vendor assigned interface IDs. Okay, all right. All right, so here's an example of a Intel MAC address on one of my devices. And if we look at this, you can see that it is, go to here. So here it is in hex. And if we take each one of those hex values and break it down to its 4 bits, we can see the binary equivalent. So the first 24 bits, the first 6 hexadecimal digits is the OUI. The second 24 bits, 6 hexadecimal digits, is the unique identifier for that OUI. And if you want to see a list of the OUIs and other information, you can go to the IEEE website. Okay, so different ways that we can look at, depending on the device, that we can look at, find out what the MAC address on your device is. Here it's from a PC. And I usually don't show configurations with the concept, but this one's kind of easy and familiar to most people, I think. So we use the command, if you're use Windows, use the DOS command ipconfig. I usually put a space here, /all. You need the /all. And what you have to look for here is where it says physical address. Okay, and that is going to show you your MAC address, in this case, on a Windows device. The MAC address should be unique, actually, in the world, but there actually have been some issues with, poor manufacturing processing, poor QA, where manufacturers will give the same second half address. This should be unique, but you may, on occasion, if you go out and buy, say, a 100 or 1,000 NIC cards from the same vendor, you may want to check to make sure they didn't kind of try and slide one by you and give you 2 NIC cards with the same unique portion, assuming that the OUI is the same on all your NIC cards. This will cause problems in your network if you have 2 devices with the same MAC address. Okay, so the MAC address, and we'll be talking about this more later when we talk about switches, but the MAC address is important, and the reason why it has to be unique is because we use the Ethernet MAC address to communicate between 2 Ethernet devices on the same network. So in an Ethernet frame, it will consist of the source MAC address, which is the device that is sending the Ethernet frame, and it will have the destination MAC address. This is the device receiving the Ethernet frame on the same network. Okay, that might be a client and let's say a server, or it could be maybe a client, maybe the router, if the IP packet we are sending is on another network. Again, this, and by the way, this is also known as a physical address or a burned in address, BIA, because the address actually is on the NIC card. And on most NIC cards nowadays, you can actually, there's ways to change those MAC addresses, and but in most cases, we don't worry about that. All right. Okay, we'll learn more about all the importance of those MAC addresses. I'm going to kind of go back here. So you saw some text come up on the screen here. So we'll learn more about how these MAC addresses are used, and when we look at the switch forwarding process, we'll also look more about how a device knows the destination MAC address when we look at the ARP process. Okay, so MAC addresses, there's 3 common MAC types of MAC addresses when we look at it from the perspective of who it is destined for. We have unicast MAC addresses. A unicast MAC address means that the MAC, in this case, the destination MAC address being unicast, being sent from this device here, is intended for one device and only one device. It's unicast, meaning it is for a single device. This MAC address belongs to just one device. And on that note, by the way, the source MAC address is always unicast because it can only come from one device. All right. So that's an example of a unicast. It's going to a single device. The MAC address belongs to a single device. All right, let's take a look at another example. Broadcast. Broadcast is a special MAC address. In hexadecimal, it's all Fs, or 48, I'm not going to write them all out, but 48 1-bits. Okay. When a switch receives a Ethernet broadcast, the switch will flood it out, send it out all ports except the port that it came in on. This is a Ethernet frame intended for everybody on the Ethernet network. Okay. We'll see how that's used later. It's very commonly used with things like an ARP request, although what this here is showing is not an ARP request. That's something, just a broadcast. I'm not sure why it's a broadcast to the network. Okay. All right, let's take a look at one more, and that's a multicast. A multicast means that it is being sent to a group of devices. Okay, in Ethernet, This is a special 01005E is a special OUI. That means that this is a multicast for IPv4. We're not going to worry about what multicast is. We don't use it a lot in this course. We'll talk more about it in other courses, like in routing, for example. But the important thing to know is that a multicast means that it is for a group of devices, and that these devices, let's say, all belong to the same destination group. And this is actually the group number as far as Ethernet is concerned. We won't get into the multicast addressing. For now, just know that what multicast is for a group of devices. Not for all, just for a group. How does the switch handle this? Well, typically a switch will handle a multicast similar to a broadcast. It will actually flood it out all ports. These NIC cards here will block it because it says, I'm not part of this group, where these devices will accept it. There's other things that we can do with multicast, so that the switch on the switch, so that switches only send it out other ports, but that's beyond the scope of this video. And we will talk about it in later classes. Okay. All right, I hope that helped you understand a little bit more about Ethernet MAC addresses. You'll definitely understand more how they're used and that when we look at the switch forwarding process.